Bismillahirrahmanirrahim. Welcome to the new lecture of physics. So today we are going to be solve some of the example of a series and parallel combination of a capacitor. So the first example is about we have, let's see, we have a voltage source and we have a C1, C2, C3. So now this is our node here. So if you can see this is a node. So in this point current is going to be divided, so the current will coming in this way and the current will coming in this way. Okay, so it means, so this is a node, so it means this is called parallel initially. So these two is going to be parallel. So once this current is coming here and this well is coming here, so it's going to be one direction now. So one is going to be one, it means the resultant of these two capacitor will be series with the C3. So what does it mean? This is parallel, if you can see. Okay, this is in a parallel. So this is in a parallel. So for a parallel we have a formula C is equal to C1 plus C2. So C1 plus C2, this is your parallel. So C1 is equal to 12 microfarad, C2 is equal to 5.3 microfarad, and C3 is equal to 4.5 microfarad. This is equal to C1 plus C2. So put out the value of C1 and C2 here. You will got your answer. Okay. Now once you solve C1 and C2, so result will be C1 and C2. So remove, so you what you can do, so this is going to be one capacitor now, which is equal to C12. So C12 will be here and this is your C3 will be on the same place. So if you can see, the current is coming here in the same direction, it's not going to be changed. So it means this is going to be in a series now. This is going to be in a series. So for a series, you know about the formula 1 over C 1 2 3, which is equal to 1 divided by C12 plus 1 divided by C13. So don't be confused yourself why we use 1 divided by C12, because C12 is the equivalent of this. Okay, so don't be write this thing again here. Okay, it's just simply C12 we already find it, so C1 plus C2, and we know about. So simply this is our series combination now. So this is series, so just simply add the value and get your C1 over 3. If you remember, I told you that whenever you are finding C value in a series combination, so just flip your value, just flip your answer. Just once you got your answer, just flip it. Okay, so now your resultant will be this now. So C1 2 3 is equal to this. So just put the values of C12. So you know about C12. C12 is equal to C1 plus C2. C1 plus C2. Then we have a C3. C3 is equal to 4.5 divided by C12 again. C1 plus C2. Then we have a C3, that's 8. So put it out here, it will be your answer. So this example is just like shows you that once we have a combination of a series and parallel combination. Okay, so coming to another example, if you can see, this example is a voltage source and we have a C1 C2 C3 C4 5 and C6 and so on. So just forget about this. This is not capacitor. Okay, just forget about this one. So now if you can see here, this is your node and this node is going to be change your current in 3 direction. Okay, so C1 C2 C3 C4, and there we have a 2 capacitor like in a series. This is another capacitor, like this is your C4, this is your C5. Just keep in mind. Okay, so what we are going to, this is your parallel now. This is your parallel combination, but C4 and C5 is in a series. So initially we need to find a series C4 5. So C4, you know about the formula of C4 5 now. What? So it can be C4 5, which is equal to 1 divided by C4, then plus 1 divided by C5. Okay, this is the formula. This is a series. Then what, once you find the series, then C1 C4 5 and C6, it's going to be in a parallel now, because current is going to be changed here. Current is going to be changed here. So this will be C1 4 5 and C6 will be equal to C1 plus C4 5 plus C6, because it's a parallel now. Okay, up to this it's fine. Then coming to this way, then current is coming in this point. Okay, then it's going to be change in a 2 direction. If you can see, again it's going to be change in 2, and it's going to be change in 2 direction. It means C2 and C3 in a parallel now. Again parallel, so C2 3 is equal to C2 plus C3. At the end now, if you can solve this, like this is your voltage, so the required equivalent of this is equal to C1456, and the required resultant of this is equal to C23, and it's going to be connect with the battery. So this is your final circuit, and just simply now again it's going to be in a series, use the formula of a series, and that's your final result. Okay, so when somebody is going to ask you to find the resultant of equivalent from this circuit though, so first of all you can see where we have a series, so use the series formula. Where we have a parallel, use the parallel formula, then make the equivalent of all the circuit like this, and then see it is in a parallel or it is in a series. If it is in a parallel, so use the parallel formula. If it is in a series, use the series formula. So coming to the another example, so given a 1 farad parallel plate capacitor having a plate separation of 1 millimeter, what is the area of a plate? So you know about the formula, C is equal to epsilon naught A divided by D. We have a D here, and we need to find the area. So we need to find this value. We know about epsilon naught 8.85 multiplied 10 raised to the minus 12. Okay, and we have a C is equal to 1 farad. So use the for putting the values of everything, and you will get your value of A, which is this required your answer. Okay, another example that we have a series and parallel combination. We have a C1, C2 and a C3. So first of all, what we are going to find out the equivalent of a capacitor. So initially, if you can see this and this, it coming to here is going to be node analysis, so it means current is going to be divided, so it's in a parallel. So what we can do initially, so it means C1 and C2 are parallel with each other, and combine these to get C12. Okay, then once you combine one, so then this and the combination of this is going to be in a series, because so this is your, let's see, this is your C3 and this is your the required equivalent in a this. So it means both are in a series. When they both are in a series, then what we can do, we can use the formula of a series, like 1 over C is equal to 1 divided by C3 plus 1 divided by C1 plus C2, or you can use behind this, like we can use that C12 is equal to C1 plus C2. So you can use this formula. So you can, beside that you can use like this, 1 over C is equal to 1 over C3 and 1 over C12. You can also use this formula as well. Okay, so this is basically the result of equivalent of this circuit. So let's come to the example. We have a 3 configuration A, B and C. So A is a simple C, 1 capacitor configuration. B have a 2 capacitor in a series, and configuration C have a 2 capacitor in a parallel. So the question is, 3 configuration are constructed using identical capacitor. It means C1, C11, C1. So all the value of capacitor is the same. So which of these configuration has the lowest overall capacitance? So which one will be the lowest? Okay, initially we have a C. Okay, so let's see, this is equal to 1. Okay, and this is equal to 1, and this is equal to 1. And again this is equal to 1, and this is 1. So in this case it's 1, in this case it's going to be 2. Okay, so it's 1, it's 2. So in this case, if you can see, but not in this, we need to be change the value. Once we can change, this is 2 and this is 2 and this is 2 and this is 2 and this is 2. So in this case C is equal to 2, in this case C is equal to 4, but in this case if you can find in the series 1 divided by 2 plus 1 divided by 2. So according to this, you just put the values. So which of these configurations is the lowest overall capacitance? So according to formula is we have, so in a series combination we have 1 over C. 1 over C, it means C value is going to be divided. So when 1 is going to be divided by greater value, so the capacitance is going to be reduced. So it means configuration B, because in the series the capacitance of a circuit is going to be reduced. So this is a formula, you can be use it out and you can be see how the configuration B is going to be correct. Okay, so coming to another example. So this is another example, that what is the equivalent capacitance of a combination show. This is your capacitance. So initially if you can see this, so if you can see this current, so current is going to be divided in two, so it means these two capacitors are in parallel. Okay, then the result will be the series in this one. So if you can see this, so what it's going to be do, so 1 over C1 is equal to 1 divided by C plus 1 divided by C, which is equal to C by 2, and the C equivalent is going to be, so C plus C by 2, because it's going to be in a series. So this is your required answer. Okay, because if you can solve it by this way, that it is in parallel, then in series, if you can see that these two are in a series, initially solve it. So 1 over C1 it can be 1 divided by C, then 1 divided by C, the result will be C by 2. Then we have a resultance, this is a resultance. So these two, this and with the combination of this is going to be in a parallel now. So then use the formula parallel. So which one is going to be true? This one. Okay, so we have another some example that determine the amount of a charge stored on either plate of a capacitor, so when connected across a 2-volt battery. So we have a value of a capacitor, we have a voltage, so we know about this formula, put the values. Another example is that if the plate separation of a capacitor is 2.0 10 raised to power minus 3, determine the area of a plate. So again we have a formula, put the values of it. So calculate the voltage of a battery connected to a parallel plate capacitor with a plate area of a 2.0 centimeter square and the plate separation is 2 millimeter if the charge stored on a plate. Okay, initially what we can do, so one thing keep in mind, always convert the unit into SI unit. This is not SI unit, so we need to be convert this into SI unit, mean in a meter. So area is equal to 2.0 centimeter square, so we need to convert to meter square. So you know about 1 meter is equal to 100 centimeters. So solve it out, your answer will be this. Okay, so then we have a formula of C epsilon naught A divided by D. So what we need to find, we need to be find the value of a calculate the voltage of a battery. So we need to find the voltage. Okay, so basically we have a formula Q is equal to CV. So but in a Q is equal to CV, what is missing? C is missing. So for that we need to find the C by this formula, because we have a value of epsilon naught, we have the value of A, and we have a value of a G. Okay, so put the values and you will have a answer. Then another example, again the same one, need to find out the separation distance, and you have everything in this. Okay, so coming to another, that C1 is 10 farad, C2 is 5 farad. Determine the effective capacitance for C1 and C2 connect in a series and parallel. In both, when C1 and C2 are connected in a series, what should be your answer, and once it's in a parallel, what should be your answer? So you know about the series, 1 over C2 1 over C1 plus 1 over C2, put the values, this is your C. In a parallel, this formula, so you know about the formula, and you can be see the difference between in a series the capacitance is going to be reduced, in a parallel the capacitance is going to be increased. Okay, so another example, so solve it by yourself, this is your homework. And another example, find the total capacitance for a 3 capacitor connected in a series, given their individual capacitance. C1 is given, C2 is given, C3 is given, 1, 5 and 8 microfarad is given. So find out the total capacitance for a 3 cap in a series. So they are in a series, so you know about the series formula. So 1 divided by C1 over C1 plus 1 over C2 plus 1 over C3. So just simply add it, but use the formula and you will have your required answer. And coming to another, it will be find the total capacitance of a combination of a capacitor. Assume the capacitance or known for to 3 decimal. C1 is equal to C2 and C3, and round your answer to this value. Okay, again I will show you the where is it, where is the figure missing, but I will I will find the picture and I will share with you. Okay, this is another example. So this is your homework. Do it by yourself. If you have any question regarding any kind of, so you can ask, and hope this lecture will really help you that how series and parallel combination is work and how we can add. So then I'm telling you, whenever you have a complex circuit means we have a series and parallel combination in a single circuit. So keep in mind always, first you need to solve series combination. Once you solve the series, then solve it in a with a parallel. Okay, just keep in initially solve series combination. When you have a series combination, solve it, then there will be a parallel or maybe there will be a series, but keep in mind solve it the series first, then solve with the parallel. Okay, so thank you for your time. See you in the next lecture.